Ever wondered how Netflix knows exactly what movie you'll probably enjoy next? It's like there's a tiny film critic living inside your screen, right? Well, not exactly. This seemingly psychic ability is courtesy of machine learning. Now, you might be thinking, what in the world is machine learning? And that's a great question. In simple terms, machine learning is a type of artificial intelligence that enables computers to learn and make decisions without being explicitly programmed. It's like teaching a computer to become a self-learning student. Think about when Netflix suggests a new movie for you. It's not just pulling titles out of a hat. It's using machine learning to analyze your viewing history, compare it to millions of other users, and predict what you'll enjoy next. It's like having a personal movie assistant, without the red carpet price tag. Yes, that's machine learning at work. But how exactly does it work? Let's dive in. Imagine having a personal assistant that learns your preferences over time. One that gets you black coffee, no sugar, no cream, every morning because it's learned that's how you like it. That's machine learning in a nutshell. But let's break it down a bit further. Machine learning is a subset of artificial intelligence that allows computers to learn from past experiences. Think of it as a child learning to walk. At first, the child stumbles, falls, but gradually it learns how to balance and take steps without falling. It's learning from its experiences, right? Similarly, machine learning enables machines to learn from data. Now, let's talk about algorithms and data sets. In the world of machine learning, algorithms are like the instruction manuals. They tell the machine how to learn from data. As for datasets, they're the real-world experiences for our machines. A dataset could be anything, from your personal assistant's recorded data of your coffee preferences to a set of images used to train a machine to recognize cats. Imagine machine learning as a cooking class. The algorithm is the recipe, and the dataset is the ingredients. The machine, or our student, uses the recipe to understand how to combine the ingredients to make the dish. And just like any student, the more it practices, the better it gets. But here's the twist. In machine learning, the machine not only learns to cook the dish but also tweaks the recipe based on its experiences. If the dish turns out too salty, the machine learns to reduce the amount of salt the next time. That's machine learning, continuous learning and improvement. So, in essence, machine learning is about teaching machines to learn from data, much like how we humans learn from our experiences. Scene script. Have you ever trained a pet? That's a bit like reinforcement learning. Let's imagine you're training a dog. You tell it to sit, and when it does, you give it a treat. This is a reward for doing the right thing. But if it doesn't, maybe you withhold the treat or give it a gentle scolding. This is a penalty for doing the wrong thing. Over time, the dog learns to associate sitting on command with a positive outcome and not sitting with a negative one. It's a classic case of cause and effect, and it's how reinforcement learning works. In the context of machine learning, reinforcement learning is a type of algorithm that learns how to make decisions based on the concept of rewards and penalties. It's like playing a game of chess against a computer. The computer's goal is to win the game. So it uses a reinforcement learning algorithm to figure out which moves will increase its chances of winning, and which ones won't. If a move leads to a win, that's a reward. If it leads to a loss, that's a penalty. But how does the algorithm know what's a reward, and what's a penalty? Well, that's where the concept of a reward function comes in. This function defines the rules of the game, so to speak. It tells the algorithm what's good and what's bad. So in our chess example, the reward function might give a positive value for winning the game and a negative value for losing it. In the grand scheme of machine learning, reinforcement learning has a unique role. It's about learning from interaction, about trial and error, about making mistakes and learning from them. It's about learning to navigate complex environments and make decisions that maximize some notion of cumulative reward. And it's being used in a wide range of applications, from self-driving cars to recommendation systems, from game playing to robotics. So just like your pet learns to behave based on rewards and punishments, reinforcement learning algorithms learn to make decisions based on rewards and penalties. Ever watched a nature documentary? Then you're familiar with the concept of survival of the fittest. Now what if I told you that this Darwinian principle doesn't just apply to the natural world, but also to the realm of machine learning? Yes, you heard that right. Welcome to the fascinating world of genetic algorithms. Imagine the process of evolution. Over time, species evolve, adapting to their environment to survive and thrive, right? Nature, the grandmaster, plays a high-stakes game, selecting the best genes to pass on to the next generation. This is the essence of the survival of the fittest principle. Now, let's bring this concept into the realm of machine learning. Here, genetic algorithms play a similar role to that of natural selection. They work by creating a population of potential solutions to a problem, each represented by a string of numbers, akin to a genetic code. This population is then subjected to a process of evolution, involving selection, crossover, and mutation. The selection process is where the survival of the fittest comes into play. The fittest individuals, or the solutions that perform best on a given task, are selected to breed and produce offspring. These offspring then go through a process of crossover, where parts of their genetic code are swapped to create a new generation of potential solutions. But it doesn't stop here. Just as in nature, where random mutations can lead to new traits, our genetic algorithm introduces random changes in the new generation, keeping the population diverse and preventing it from getting stuck at local optima. And voila! With each generation the solutions get better and better, gradually evolving towards the optimal solution. This is how genetic algorithms help in solving complex optimization problems in machine learning, from scheduling tasks to training neural networks. Just as nature selects the best genes for survival, genetic algorithms select the best solutions for a problem. So, next time you watch a nature documentary, remember that the same principles are at work in the code that powers your favorite apps and devices. Isn't that something? Ever tried to recognize a friend's face in a crowd? That's a bit like deep learning. Deep learning, a subfield of machine learning, is like an expert at playing Where's Waldo in a sea of data. It's all about training computers to recognize patterns and make decisions just like we humans do. But instead of using our eyes and brains, it uses layers and layers of artificial neural networks. Imagine you're trying to find your friend Bob in a crowded park. Your brain doesn't just look for Bob's face, it looks for his distinctive red hat, his tall height, his love for striped shirts. You're using multiple layers of information to recognize Bob. Deep learning works in a similar way. When a deep learning model is given a task, it starts by identifying the basic features, just like you first look for a red hat in the crowd. This is the first layer of the artificial neural network. Then, it combines these basic features to form more complex ones. This is like recognizing that the red hat is attached to a tall person. As it goes deeper and deeper, it can recognize more complex patterns, just like you finally recognize Bob from his specific combination of features. Now let's transition this analogy to a more practical application. Consider a deep learning model trained to recognize images of cats. The first layer might recognize simple shapes and colors, the next layer might recognize more complex features like ears or tails, and finally, the deeper layers would be able to recognize a full cat image based on these features. Deep learning is the secret ingredient that powers some of the most innovative technologies today, from voice assistants that understand our commands, to self-driving cars that can navigate busy streets. It's like having a super smart, pattern-recognizing friend who's always ready to help you out. Just as your brain uses multiple layers of information to recognize a face, deep learning uses multiple layers of data to make predictions. And with that, we've dived deep into the fascinating world of deep learning. So we've journeyed through the fascinating world of machine learning. We've delved deep into the intricate workings of reinforcement learning, where machines learn to make decisions by trial and error, just like a child learning to walk. We've seen how a machine can learn to play a game, solve a puzzle, or navigate a maze all by itself. We've also explored the Darwinian concept of survival of the fittest, translated into the realm of computing through genetic algorithms. Here, potential solutions evolve over generations, with the best traits being passed on, to solve complex problems in an organic, dynamic way. And finally, we've plunged into the depths of deep learning. We've seen how artificial neural networks, inspired by our own brain's architecture, can learn to recognize patterns, process language, and even create art. Next time Netflix recommends a movie, you'll know there's a lot of learning behind that suggestion.